So far we have been finding integrals, definite integrals, by using Riemann sums, by using the trapezoidal rule, and then we recently learned the fundamental theorem of calculus. Well, today we finally get to start using our calculator. So at the end of this lesson, you'll be able to use your calculator to evaluate a definite integral. Okay, the first thing that we're going to do, I'm just going to go through the keystrokes that you're going to press to find a definite integral on your calculator, and then we'll do an example and I'll actually pull the calculator up so you can follow along with me. So we are going to go to Math 9. Remember, when we find a derivative, we go to Math 8, but this time we'll go to Math 9. When you press Math 9, you are going to get this, something that looks like this, on your screen. So it's going to look something like that. We've got 4 boxes that we will need to fill in. In the first box, you are going to put the lower limit. In the upper box, you are going to put the upper limit, and you always have to, this will be always the smaller number on the bottom and the bigger number on top. If you do not do that, it will come up as being an error, so just a quick heads up on that. Okay, this in the part right here, you're actually going to enter the function. You can actually either enter the function, so if the function were 2x plus 5, you could actually just enter 2x plus 5, or you can put your function into y1 of the calculator, or actually you could put it in y2 or y3, so you're just designating what function you want to take the integral of. And this is always going to be our dependent variable in the situation. So what variable are we taking the integral with respect to? We will, in our cases, always use x. So even if in the problem there is a different variable, our calculator relies on us using x as our independent, this is not dependent, independent variable, so that is what we'll be plugging there. So I'm going to go ahead into an example, and again, I'll get onto the calculator to show you how that works. All right, so we have the integral from 2 to 5 of the function negative 3v plus 4 dv. And notice we've got a different variable, but that should not make a difference as we work through the problem. So I'm going to go ahead and go to my calculator right now. Okay, so I'm in my calculator, and I'm going to go ahead and press in the function. We'll have negative, I went to y equals negative 3. I'm going to use x instead of v, x plus 4, and then I'm going to quit out of there because I'm just storing my function right now. So I'm quitting out of there, and then like I said before, to get the derivative, the integral, we're going to be hitting Math 9, and when I do that, there we go, just like what I said was going to show up. We were going from 2 to 5, so my lower number is 2, and then I can just go up. My next number is going to be 5. And then I'm going to go over which function I'm going to use. Well, I saved my function in y1, so I'm going to hit alpha trace, and it will show me to y1, so that's the one I'm going to choose. And then over, and then our variable that we are using on the calculator right now is x, and then we just press enter. And voila, I get negative 19.5 as my answer. Please notice I'm just going to show you if I would have done that same thing. We have Math 9, and I still put in 2 and 5. I could have just entered the function, so I could have put negative 3x plus 4 in there, and my variable is still x, of course, and then pressed enter. I will get the same thing. I just prefer to put my things in y1. It's just easier, I think, to type things into the y equals program as opposed to putting it right into the problem. So that's what I would suggest when you do that. So we ended up getting an answer of negative 19.5, and that's pretty much all there is to it. So hopefully now you can use your calculator to calculate the definite integral of a function.